Extension methods are one of the most attractive but lesser used features of C#. They add new functionality to existing classes without breaking object-oriented design principles. Use them wisely, and your apps will be easier to read and maintain, and you can spend more time working on business features and less time trawling through fragmented and duplicated code. Welcome to C# Extension Methods, one of the courses in Pluralsight's C# learning path. My name's Elton, and thanks for joining me. I'm a huge fan of extension methods. They're really easy to use and easy to write, but you need a good understanding to make the best use of them. That's what you'll get from this course over the next 90 minutes. So let's get started. This is an extension method. The chances are, if you've used C# for any length of time, you'll be familiar with this. I've declared a list here with some initial values, and I'm calling count to confirm how many values are in the list. Count is a method which is part of the link library in .NET, which you get from the system.link namespace. The method is defined for the IEnumerable of t interface, so you can use the count method with any class that implements IEnumerable of t. But count isn't part of the interface, it's an extension method. That means the logic for the count method is defined separately from the IEnumerable of t interface and any classes which implement it, but it can be used with all those classes. List of t, dictionary of key and value, typed arrays, and even strings are all examples of IEnumerable of t where you can use the count method, but they don't have a common class hierarchy. If I wanted to do something similar and have a new method available for one of my interfaces, I'd have to add the method to the interface, then write the code in every class. Or put it in an abstract base class and have all my classes inherit from that. If I add a new class that implements the interface, I have to do the same, inherit from the same abstract base class, or write my own method logic. Writing the same logic in every case violates the DRY principle, don't repeat yourself. Duplicated code is a waste of effort, and it's a nightmare to maintain because the implementations tend to drift. Someone fixes a bug in one class without realizing that there are other implementations with the same bug, so those other classes miss out on the fix and the same bug crops up in other places. Centralizing logic in a base class is a better option, but only if it makes sense for those classes to be in the same hierarchy. You shouldn't reorganize your class structure just to share a method. And anyway, that only works for your own code. You can't modify the class hierarchy of somebody else's library. Now instead, you could write a utility class and put the helper method in there, so the method takes an object which implements the interface. But then you end up with a sprawl of utility classes that make code even more difficult to read, and it's hard to help people discover those utility classes, so they tend to get duplicated too. This is where extension methods come in. They let you extend an existing class or interface in your own code or someone else's code, using a single implementation of a method which is easily discoverable. If you're familiar with the solid principles, extension methods are the O. They make any type open for extensibility while keeping it closed for modification. Next, we'll look at using extension methods in a demo so you get a good understanding of the basics before we go on to write our own extension methods.